Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, which is part of the Cisco Networking Academy curriculum. And in this activity, this video tutorial is going to be on Discovery for another fantastic Cisco Learning Labs activity where we're going to get to take a look at EIGRP Stub routing. Now, this activity is going to be similar to, but not identical to lab, I believe it's lab 2-2 or 2-1 out of the Networking Academy curriculum where we work with stub routing a little bit. And again, this is another fantastic activity to walk you through the setup and configuration steps. And so let's go ahead and dive in here. You can see it wants us to take a look at the routing tables on the HQ router. So we're going to go from user exec to privilege exec and into global config. And I'm just going to say do show IP route. Again, you don't need to be in global config to do this. However, at some point we're probably going to need to get into global config, so I'll go ahead and put us there now. And if I only wanted to see the EIGRP routes, I would say do show IP route EIGRP. And so what do we see here? Well, we have a /24. It looks like we have a summary, which is a /23 there, and then we have an EIGRP external route. And now let's go ahead and take a look at the show IP EIGRP neighbors detail. So do show IP EIGRP neighbors detail. And as you can see, we only have a single neighbor right now, and that is the neighbor out Ethernet 00. 172.16.1.2 is the neighbor's IP address. And we are definitely in Autonomous System 1. So if I were to say do show IP protocols, we would see the additional information here for EIGRP Autonomous System 1. We can see that automatic summarizations disabled. We can also see that we have our K values here, our metric values, and none of those have changed, K1 through 5. Maximum number of paths right now is 4, so we could do equal cost multipathing or load balancing across 4 paths. And the maximum metric variance, right? Remember we talked about unequal cost load balancing or multipathing. Right now variance is at 1, and that is the default value. So let's go ahead and we're going to kick a debug off here. So I'm going to say, and actually we're going to go into interface loopback 0 first, and we're going to do a do debug EIGRP packets terse. And so we're actually going to see information about all of the different packet types. I'm going to go ahead and type shutdown, remembering that the hello and the acknowledgement packets, that those are not sent reliably, right? So remember that. Hello and acknowledge are not sent reliably. However, the rest of the packet types that we've talked about are sent reliably. So we get some information here. So I'll say do you all for do undebug all. And it wants us to go ahead and take a look at the query message that gets sent out. You can see right here, sending query on Ethernet 00. And it's sending the query because we've just removed the loopback interface. So if I say do show IP interface brief, you can see our loopback address, which is 10.1.0.1, is administratively down. So when we removed it, the headquarters router is doing exactly what EIGRP expects it to do. And that is it's sending out a query message asking neighbors, do you have an alternate route to get to the network that's just gone away from, that I've just lost, which is 10.1.0.1. And so if I were to say do show run interface loopback 0, we can see that that is a /16. And so this is the type length value that's being sent out, trying to find another alternate path to get to 10.1.0.1/16. So if we take a look here, there is no other path, right? Nobody else is connected in here to this headquarters network where the /16 resides. So if we come back, you'll see that he receives an acknowledgement packet, right? Or actually is in-queuing it up here from the neighbor, right? And responding saying he does not have an alternate path to get there. All right. So now we're going to talk about some of the EIGRP stub options. And this, what we just saw there with the sending of the query, that becomes very, very important, because what's going to happen is when we declare a router to be a stub, that router will no longer be sent queries. All right, so we talk about the different options for stubs. So connected. Now by default, when you type in EIGRP stub, by default, you're going to be advertising connected and summary. And this, among the use cases that I've seen, is probably one of the most popular configurations. And we can mix and match. So what I mean there is that connected, summary, static, and redistribute, those are not mutually exclusive. So I could say connected and redistribute, or I could say summary, redistribute, and static. And then by default, it's just connected and summary. Now, the only caveat here when we're talking about the options is when we're talking about the receive only option. And so what this option is saying when the stub is declared to be receive only, it's that he is not going to send any updates. Not going to send any, or I should say any routing information, any routes learned from EIGRP, any EIGRP information, right? Now, he can still receive, and that's why that the keyword there, receive only, he can still receive information from neighbors with respect to EIGRP routing information, but he's not going to be sharing any of his EIGRP routing information with any of his EIGRP neighbors. All right, so let's go ahead. We're going to bring back the loopback interface here. I'm just going to say no shut. And on the branch router, let me make sure we get this right here. So I'm going to transition over to branch 1. So it looks like we're going to be making branch 1 our stub, right? And this kind of makes sense because, again, the branch 1 router has only one way across the LAN here, or the WAN here, to get to the HQ router. So again, perfect candidate to become a stub router. So let's go from user exec to privilege exec and into global config. And we're going to say router EIGRP 1. First, let's take a look and see what we have here. Do show run section EIGRP. All right, so just basically the network 0000 statement. We've got EIGRP running on every interface. So if I say do show IP EIGRP interfaces, you can see it's running on Ethernet 0001 and on our loopback interface. And what else? We're redistributing static network. So do show IP route EIGRP. So I'm learning 2 routes. Now we've already seen the 1 route there, right? That 10.1.0.0. We've already seen that. We're learning that from the headquarters router. And we have a summary network to null 0. And so this is very important. And this is going to be placed into our routing table by default. So why do we have this entry null 0? So let's talk about this for a second. So we have a summary, right? 192.168.16.0/23. If for whatever reason we have traffic that's sent to one of the networks in the summary, but yet that's not configured in the summary, because sometimes you end up with summaries that include prefixes that you simply don't have any more specific routing information for, and they may not even be in use. So inside the /23, we have 2/24. So really what this is 192.168.16.0/24 and .17.0/24. So we end up with this null 0 entry because let's say that I do the summary, but we don't have that network configured in our setup yet. So we put the null entry here because it basically means that any traffic that gets sent to a member network of a summary, and that member network doesn't exist, the traffic is going to get black holed, right? So that's what's going to end up happening. So let's go ahead and clear our screen here. and we're going to turn our router branch 1A into a stub. And we simply do that by saying EIGRP Stub. Now remember, when we do this, we are now redistributing connected and summary, right, by default. And we're going to see that here in a second. And keep in mind that this is definitely not something you want to do in the middle of the production day. Because as you can see, when we're changing the EIGRP router branch 1A to a stub router, an EIGRP stub, it will tear down the neighbor adjacency with the headquarters router, which is what it did right here. So this is definitely what I like to call a resume generating event if you do this in the middle of the production day. All right, so we can see that the adjacency came back up. We formed a new adjacency. So if I were to say do show EIGRP neighbors detail, you can see that we still have that same adjacency, right, out of Ethernet 00. And then let's go ahead and on the HQ router, they're asking us here to turn off debugging. I think we already did that. So show debug. Let's see if we're debugging here. No, we're not debugging. We already turned it off. All right. So on the HQ router, if I were to say show IP EIGRP neighbors detail, and this command is a fantastic command to run from the neighbor of the stub router, because I can tell from here, and again, we're on the HQ router. So if I come to the diagram, right, remember, we're on the HQ router running this command, all right? And the command is show IP EIGRP neighbor detail. So what kind of detail are we going to get to see? Well, the most important information is right here. It's connected and summary. So we know right now that one of two commands had to be run over on branch 1A. We either had to say EIGRP stub, which is one way to get connected and summary in there as options, or we said EIGRP stub summary or connected, or and connected, right? So either of these commands would have resulted in that being the option. So again, it shows that we're a stub. It shows that we are advertising connected and summary routes. And most importantly here, because one of the major factors with distance vector protocols, and specifically with EIGRP, is the ability to limit the size of the query domain. So by declaring by declaring the, and we'll leave that there for a second, by declaring the branch 1A router as a stub at this point, what we're saying is we're telling the HQ router, if you have queries, do not send them to me, right? So we've just limited the size of the query domain, because now the HQ router, based off the output that we were just looking at, right? The HQ router now knows I am suppressing queries to that neighbor. So if I lose a route, and I guess that's why they had us do it initially there, right? So we initially took away that loopback address, and what did we see in the debug? Well, we saw a query message. A query message gets sent over to branch 1A. And what that query message says from HQ, from the HQ router, is the HQ router is asking branch 1A, hey, listen, I just lost 10.1.0.0/16. Do you have an alternate path to get there? And if you do, please let me know, because then I'll install that into my routing table. And if you don't, please tell me that as well. That way we don't have a query that gets stuck inactive, right? Or I should say a successor route that gets stuck inactive. So we want, or yeah, I guess that would be technically accurate to say that. So, because it was probably the successor route at one point. So we don't want it to get stuck inactive is the key, right? So we get that reliable transport protocol to make sure that we get a response back from branch 1A telling us, hey, I don't have a route to get there, I'm sorry. At which point it'll then be pulled from the HQ routing table. So again, This is some great output here from the neighbor, right? We get this output from the neighbor. So from the neighbor, I'm able to easily tell what's the deal what's the deal with the branch 1A router, what's it set up for, and if it's set up as a stub, we're going to see that, and we're also going to know we're suppressing queries. And this is done automatically for you because this is one of the major reasons behind doing stub routers in EIGRP, is to limit that query domain. All right, well, let's clear our screen here, and let's slide down a little bit. All right, so on the branch 1A router, they're asking us to do do a show IP route. So we'll say do show IP route, and we'll take a look at what we see there. Now, you can see that on the branch 1A router, I'm learning about the EIGRP route, which is the loopback interface here on the HQ router. So we have our entry for that there. And then I also have my entry, and I apologize, I went too big there. Have the summary entry pointing to null 0, and you can see we have the /24 entry for the 192.168.16.0/24, right? So we have these routes that we've learned in EIGRP from the HQ router. So now what we're going to do, and this is to show that the stub router, again, remember, changing a router to a stub doesn't limit the information that the router can learn. It limits the information that the router is going to share. So if I go back over to the HQ router and I say show IP route, you can see that we've got the connected route and the summary route. But what route did we lose? Well, if I scroll back up here, we'll see that we lost that external route that was in the routing table. So here's that external route right there that is now no longer in the routing table. We only have the connected route and the summary route. And so if I were to mouse back over here, and the connected route is the 192.168.0. So this is that loopback interface over here on branch 1A, right? And then we have and we've summarized the 16 and 17 together as a /23. So we haven't done anything yet with the 192.168.18. So I've got the connected and the summary, and we're able to see those from the HQ router's perspective right down here at the bottom. And there they are, the connected and the summary respectively. So we've just verified the routing table on the HQ router. So now what we're going to do is now let's transition and configure branch 1A as a stub, but we're going to throw a little wrench in here. We're going to say EIGRP Stub, and we're going to do just connected. Now again, remember, every time you do this, it's going to tear the adjacency down and then bring it back. So what we want to do here is say show IP route, and what are we going to see, or what would we expect that we're going to see? We're only going to see the directly connected networks, right? Because I've said stub connected. In fact, if we say show IP EIGRP neighbor detail, you can see that we are only advertising. So branch 1A is only advertising connected routes. So if I clear that here, and we'll go back over to branch, or the diagram. So we're advertising this route, which is directly connected, and this route, which is directly connected. And which route are we not advertising? You don't see the /23. There's no summary being advertised, right? So we no longer see that, and we can confirm that when we look on the HQ router tab is disappearing on me there. When we look on the HQ router, right? So here is that directly connected network, and here is the other directly connected network, 192.168.16. That's the transit network between branch 1A and branch 1B, and then I see the 192.168.0.0/24 here as the loopback interface. So again, conclusively proving that when we changed it to connected, all we're seeing at this point are the connected routes. Okay, so we've validated that. Now we're going to go ahead and we're going to change branch 1A to be receive only. So if I were to transition here to branch 1A, and we're going to say EIGRP Stub receive only. And this is again going to tear down the adjacency and bring the adjacency back up. And so remember, this doesn't change what branch 1A can learn. So if I say do show IP route, I'm still learning the EIGRP routes from the headquarters router, right? But when I come onto the headquarters router is not learning anything from the stub. And so again, when we use that receive only option, what we're saying is, we're saying that the stub still is interested in receiving EIGRP routing information. However, he's not going to share any EIGRP routing information. And now what's interesting is, the book kind of talks about the use case and the applicability of doing the receive only stub option. And really, I've never seen it used before, and the only use case that I would ever imagine is the way the book describes it, which is if you're doing NAT with PAT. So you've got a single outside interface, and you've got IPNAT outside there, and you're doing IPNAT inside off of your local LAN segment, and your entire network is hidden. And so in that case, do you need to share any EIGRP information with your neighbor? Probably not. In fact, the neighbor HQ is probably just sending you a default route for you to get out. So if you're running EIGRP with each other. So, and that's a very valid point. But again, this receive only, not many use cases, especially in a larger enterprise environment. So let's go ahead and take a look at show IP EIGRP neighbors and detail. And you can see here where we end up with the receive only option, right? Shows right here, advertising no routes. And still, it's suppressing queries. And this is going to be irrespective of the options we use, right? Connected, summary, redistributed, whatever the case may be. It will always suppress the queries, right? So this is an always type thing. As soon as we say stub, we are going to always suppress queries as the stub from the HQ router, because this is the information that I am signaling from the stub to the HQ router inside of the hello packets. And specifically, it's the type length values in those hello packets that are enabling that stub router, branch 1A, to tell HQ, hey, I'm a stub, don't send me queries. So let's take a look at that. So if I were to come back over here to branch 1A, in fact, it looks like we've got, if I were to pull branch 1B up, let's see what we have here. We'll go from user exec to privilege exec, show run, section EIGRP. EIGRP is not running. What about show IP interface brief? So we've got those two loopback addresses, and neither is being, what about show run include? Nothing's being redistributed there. So if we come back over here, we're going to change this, but first we're going to go ahead on the headquarters router. We're going to kick off a debug here, and we're going to say debug EIGRP packets, hello, and there should be a detail option. So it's got verbose, it's got terse. All right, and maybe terse is going to do it for us here. And no, that's not what we're looking for. So let's say you all, and I think what I want is, on the newer code, it's detail, and it's going to give us the type length, and that is not going to give it to us either. Let's see here, you all. So debug, is it IP EIGRP? I don't think this is it. No, that's not it. Debug, it just might not be on this version of code. Debug EIGRP, and we want to do packets. We want to do the hello packets, and I want detail, but it doesn't look, let's go with this option. I don't think this is going to give it to us either. It's not. So let me go ahead here and pull up this alternative setup that we have here. So, and just to draw it off to the side real quick, what you're looking at is you have router 6 is at the top. We're going to declare router 6 to be a stub. He connects into router 5, and 5 connects out to 2 more routers, and then they connect down here like this, and we've got links like this. So this is router 6, this is router 5. We are going to set 6 as a, as a stub. All right, so let's go ahead and do that right now. So let's take a look here, and I'll show you the debug that I'm looking for. And in fact, now that I say that, I have a feeling this is version 12.xcode, and it is. So we'll do it in the opposite direction, even though that doesn't make much sense. So 6 is going to be, we'll make 5 the stub. And so, because I want to get this debug, there's a specific debug I'm looking for, and it's debug EIGRP packets hello, and you'll see that there's an option here, detail, right? So, and so this detail option is in the 15, I'm running 15.3 code, and it's here, and apparently it's not in that 15.1 code. And so this is going to give us the TLV values, and this is exactly what we're looking for. So if I come over here to router 5, and let's say do show run section EIGRP, you can see that we've got the classic mode EIGRP configured here with the router EIGRP 100. We're not running named mode, and so let's go ahead and go into router EIGRP 100, and we're going to say EIGRP Stub, and these are the different options. Remember, so connected does only connected. We're going to talk about the leak map here in a second. Receive only, redistributed, static, and summary, right? So if I wanted to do only connected, I would say connected. But before we do this, let's take a look at router 6, and you can see that router 6's only connection is out FA01 to router 5. And here are the hello packets that it's sending and hello packets that it is receiving. And so we're going to be interested in the hello packets that are being received. And specifically, we can see the type of 1 and a type of 4. And let's see what changes when we flip router 5 to a stub with only connected routes. And you can see there the neighbor adjacency went down and now is coming back up. And we're looking for the received hellos. We can see the received hellos right here. And I'm going to give it a second here, and because the F5 type is going to go away, and we're going to talk about that in a second. So I'm going to kill the debug, right? Because we've got the information that we want. So when we take a look here real quickly, this type 5 is for multi-topology routing, or MTR routing, which is something that I was actually fortunate enough to talk with Donnie Savage at Cisco Live this year. And Donnie is really sort of the brain trust behind EIGRP and has actually rewritten almost every line of code at some point. And I had the opportunity to ask him about this type F5 code because it's not in the informational RF, or I shouldn't say RFC, but the draft RFC for EIGRP, and he explained that it's related to multi-topology routing, that it just simply didn't take off like they thought, but that it's still in here. It's still a part of the code. So if I come a little further down, you can see that we have the type 1 with length of 12, and then we get the value or the vector, right? Now, what do we notice here? We're receiving this hello, and this is coming in from the stub. So the stub is telling us or providing these values to us. So it's interesting that we're getting this type 6, length 6, 009. Let's turn that debug back on, and I'm going to change it from connected to EIGRP stub and just summary. And let's see what happens. We know that the adjacency is going to be torn down. Let's keep our eyes on that type 6 value that we're receiving. And as you can see, and we'll go ahead and kill it right here, we'll say you all, right? So when we're receiving hellos from the neighbor, what changed, right? So the type is 6, the length is 6 in bytes, it's 6 bytes, and then here is the vector or the value. So what is that saying to us? This is saying, because this is coming in from, it's being received, the hello is being received from router 5 on the FA01 interface. And when it says 000 Charlie, that value equals a stub who is only doing summaries, right? Because what was the value before here when we said connected? And in fact, I'm going to have to roll back up because now I am drawing a blank here. I think it was 000 delta. Let's go back up and check that out. 0009, right? So we'll roll back down to the bottom here. So when it was 0009 for the value in the hello packet, remember, and again, this is a hello packet that these TLV values are showing up in. So 0009, and in fact I should probably put it over here, 000 Charlie is just a summary stub. 0009 is only a connected stub, sorry. All right. And now I just realized I'm going to clear the screen. So having him over here is not going to help us out too much here. I'm going to clear the screen and then we're going to come back. So this is just connected, right? So only connected. So let's take a look again, right? And this is, I love the debug output because it gives you really, some of the most accurate and informative information that you could expect to see. So let's kick the detailed debug on again, and now let's go ahead and change it to just EIGRP stub. So if I say do show run section EIGRP, you can see that we are a stub, and because remember, I didn't say connected summary, those are the defaults when you declare the router to be a stub. So if I come back over to router 6, now what's the value that we see? 000 delta, right? Does everybody see that? I'm going to continue to let this go, but you should be able to see that we're receiving, and it's not when we're sending, right? It's when we're receiving. And when the router's not a stub, we don't even get the type 6. So let's go ahead and do this. Let's say no EIGRP stub. Do show run section EIGRP. So I've pulled the stub out, right? So now I'm no longer, router 5 is no longer a stub. So, and there's that multi-topology routing flag, which is at F5, and there it is again, and that we're receiving it. However, it's going to go away because we're not doing multi-topology routing. But what do you notice? What type is not showing up? Exactly, type 6 is not showing up. So let's kick the stub on one more time. So what if I were to do a receive only? So EIGRP stub receive only, what's that going to look like? And this is great because, and there it is, 0008. So when I declare myself, or declare router 5 to be a stub receive only, it is going to be a type of 6. It is going to be a length of 6 bytes, and a vector or value of 0008 right there, right? And so this is how the stub router is telling the other routers not only am I a stub, so let me, you all here, let's stop that. So what he's saying is, not only am I a stub, which is the type 6, which is a type of 6 in the TLV value, but I am receive only, which is going to be the 0008. So if I were to, real quickly here, let me pull this back up. I had an RFC here earlier. If I were to say, let's go to Google real quick, and if I were to pull up the informational RFC that is out there, the draft, which is an incredibly good document to read through. So draft, Savage, and there it is, EIGRP. It was literally updated on August 16th, and here is, this is actually Donnie Savage right here, and he has got to be one of the nicest individuals I've ever met, and will spend as much time as you want talking about EIGRP with you. So let's click on, and I don't want to see that one, I want to see, I guess we'll go here and then work our way up. It's interesting where it shows only 3, but when you click on 3, it shows 4. So 4 is what we want. This was literally updated less than a month ago, and it's got some really good information. So I'm going to pull the PDF version up, and as we come down here, you'll see we're going to be looking for the hello packets. So I believe that was in section, where are we at here? So here are the generic TLV definitions, and type 6 is the peer information type. So let's make our way down here to page 54, 676, page 54, and we're getting pretty close here, 51, 52. All right, so here we go. And you can see that the generic types, that type 6 is for the stub, and it's the peer information type. Now, what's interesting is in the open standard that's that they've really, the draft for making EIGRP an open standard, that it says this TLV is reserved and not part of the document. And this is one of the things you'll hear, is that EIGRP, while they have written this draft here, this internet draft, they have not released the stub functionality as part of the initial release. And so that's why it says that it's reserved. But again, when we see type 6, that is exactly the type that we're seeing. So let's cruise down a little further here, I believe. And these are the flags, and I'm not sure, I was looking for, I'm not sure the values are in here. I'd looked at that before, and I'm not sure it gives me the values that I'm looking for, specifically with the stub feature. In fact, let me do a quick search here, and I'm going to search on stub. And interestingly enough, stub is not even mentioned in the document. And so again, I looked at this before, and I believe that the reason it's not mentioned in here is because that functionality is not included. But again, when we see that type 6, we know that that is that peer information. Let me pull that back up here. Peer information type, right? So again, marrying the debug output with the informational internet draft RFC, we get some really, really great information here. We know the value of what the router, what the stub is going to report to its neighbors is going to be. So if I'm, and let me, I think we did stub summary there. Yeah, or was it receive only? Let's see, do show run section EIGRP. Yeah, so for receive only, we know the value that I'm going to advertise to my neighbors is going to be 0008 in the TLV fields that go out in the hello packet. So again, some fantastic information. I'm glad we had a chance to look at this, because again, it appears that on the early 15 code that we are working with here, that is not an option. Again, this is the 15.1 code, and let me drop this down here. That is the 15.1 code, and it just simply does not appear to be available on the HQ router. If I do that show version, it should say 15.1 toward the top, and it does. However, when we go to do that debug EIGRP packets hello, there is no, and I misspelled debug there, hold on one second. So debug EIGRP packets hello, there is no detail option, unfortunately. So, but again, with 15.3 code, it is there, and I've actually seen this. It definitely exists on the 15.4 and 5 branches that are out there as well. All right, so let's go ahead and transition back to the activity. And that is pretty much it for this stub functionality. Again, let's kind of recap what we talked about. We looked at the routing table on the HQ router and the branch 1 router, branch 1A. How can you tell from the HQ router how branch 1 is set up? You can do a show IP EIGRP neighbors detail. If there is no information here about stub or suppressing summaries, then the neighbor is not configured as a stub, because we know that if he was, we would see this information right down here toward the bottom, which is it's a stub peer, and what is he advertising? Is it connected? Is it summary? Is it redistributed? What is it going to be? Or is he receive only? And remember, it doesn't impact the information that the stub router is going to receive, right? When you configure the router as a stub, it only impacts the information that the stub is going to share with other neighbors. All right, so this is going to wrap up Discovery 4, the Cisco Learning Labs activity on EIGRP stub routing. We're also going to get a chance to take a look at this again in the Cisco Networking Academy lab that we did, where we set up stub routing. All right, thanks for watching. I hope you're enjoying the Labor Day weekend, and I will see you all not this coming Monday, but the following Monday. Have a great weekend.